Hi, everybody. Welcome back. Today, we're going to move on to solving systems by substitution. So the past couple days, we have solved a system of equations by looking at their graphs. We would graph each lines and we would see where it would intersect, and that point would be our solution. Today, the big difference is now we're going to be solving it algebraically. So let's go ahead and get started. The first equation is 3 is equal to x. My second equation is y is equal to x plus 6. So what I'm going to do is I'm going to take what x is, a 3, and I'm going to substitute it into my second equation for x. So instead of saying y is equal to x plus 6, I'm going to say y is equal to, what is x? 3. Good. Plus 6. So now that I substituted it in, I can go ahead and solve this equation. Y is equal to, what is 3 plus 6? 9. Great job. So all I did is I took my equation. It had both x's and y's in it. We've never learned how to solve an equation with two different variables, so I replaced it. So now when I'm working with my equation, I only have one variable. The final thing you do need to do is write your solution. Just like previously, when you graphed your lines, you had to write your solution as a point. We're going to do that as well. Remember, our points always go x comma y. So my x value, lucky me, was given 3. My y value is 9, and so that is my solution. You can always go back and double check your graphing for these. So let's go ahead and look at this one on a graph. So I'm going to type in my first equation, 3 is equal to x. And you can see that red line on the screen that appeared over here. That's my equation for, or my line for it. Now I'm going to enter in my second equation, y is equal to x plus 6. And if you look at that blue line that appeared, that's my second line. What I want to do is I want to figure out where these two lines intersect. So if I drag this down, you will see that it intersects right here at this dot. And if I kind of hover on it, you'll actually see that it intersects at the point 3, 9, which is what we got in our notes. Desmos.com is a great resource to use if you ever want to double check your work to make sure you're doing things accurately. Let's get back to those notes. Looking at number 2, y is equal to 5x, and I have the equation 2x plus y is equal to 28. So again, I have y is equal to this thing right here, 5x. So I'm going to take that and put it in place of y in the second equation. So I'm taking y out, I'm throwing it out the door, and I'm going to put a 5x in its place. So instead of saying 2x plus y, I'm going to say 2x plus 5x because that's what y is, and that is equal to 28. From there, I go through and do all of my equation solving steps. What is 2x's plus 5x's? Good, 7x. That is equal to 28. Final step to get x by itself. Good job. We are going to divide both sides by 7. I end up with x is equal to 4. So I have an x value, but do I know what y is? No, I definitely do not. What I do know is that y is equal to 5 times my x. I also know that x is equal to 4. So I'm going to go back and do one more substitution. Instead of saying y is equal to 5 times x, I'm going to say y is equal to 5 times 4 because that's what x is. So y is equal to 5 times 4, which is 20. So now I have an x value and a y value. So I can write my point 4, 20. Let's go ahead and try another one. So for number 3, I have y is equal to 3x minus 5, and my second equation is a negative x plus y is equal to 9. So y is equal to this entire thing right here. So what I'm going to do is I'm going to put it in place of y right here. So I'm going to rewrite my negative x plus. Whenever you substitute something into an equation, you usually would use parentheses when it's something this large. So instead of saying y, I'm going to say that entire expression, 3x minus 5. and that is equal to 9. Well, in this case, there's no number outside it, so I can just rewrite this as negative x plus 3x minus 5 is equal to 9. Looking at this negative x, don't we normally put a negative 1 with it? Great job. Now we're going to go ahead and combine our like terms. So what is negative 1x plus 3x? Good, 2x. I still have that minus 5. It's still equal to 9. From there, I know you got this. We're going to add 5 to both sides. Good. So I have 2x is equal to, what is 9 plus 5? 14. Final step, divide them both by 2, and x is equal to 7. So I have what x is. Do I have all my information to write my intersection point? You're right, I do not have it. So what I needed to do then is go back and substitute it in. Now the neat thing is I could do it in either equation. However, there's one equation that's easier than the other. So I could go back to the second equation, negative x plus y equals 9, and put a 7 in place of x. But in the first equation, I already have that y is equal to 3x minus 5. So this would make the most sense to substitute it back into there because y is already by itself. So y is equal to 3. Now remember, we said x was equal to 7. So we're actually going to take that x out and we're going to put a 7 in its place. And then I have minus 5. So y is equal to, what's 3 times 7? Awesome job, 21 minus 5. And 21 minus 5 is? Good, 16. So now I have an x and I have a y, so I can write down where they intersect at 7, 16. And you can always go back if you think the number seems a little weird, and you can regraph this. So if we go back to that decimals graph that we already had, we'll just kind of pull that back up and we change out our equations, we can actually go and retype this in just to make sure that we're on the same track. Our first line was 3x minus 5. Our second line is a negative x plus y is equal to 9. And again, we don't see where it's at on our graph, but if we drag it down, you can see right here is where they intersect. And if I click that point, 7, 16 is our intersection point, just like what we found. You can't go back and double check on a test, but you sure can do that when you're doing your classwork to make sure you're knowing and understanding how to solve these algebraically. Let's go on to number 4. I have y is equal to 2x plus 7, and I also have that y is equal to 4x plus 4. It looks quite a bit different, but really, these are my favorite because they're the easiest. I'm telling you that y is equal to 2x plus 7. So same idea. I'm going to replace y in my second equation with that entire expression. So instead of saying y equals 4x plus 4, I'm going to say 2x plus 7 is equal to 4x plus 4. So now I just go through and do all of my equation solving steps. How do I move a positive 4x to the other side? Great job. I'm going to minus 4x to both sides. When I do that, what does 2x's take away 4x's? Awesome. Negative 2x plus 7 is equal to 4. I'm not done yet, however. How do I move that positive 7 over? Great. I'm going to minus it. So I get a negative 2x is equal to a negative 3. Final step, I need to divide both sides by that negative 2. And in this situation, it may be easier for you to rewrite these as a decimal. X is equal to, what is negative 3 divided by negative 2? Good, it's a positive 1.5. And that's an acceptable answer. It's okay if you have a decimal or a fraction as an answer when you're solving by substitution. So now we're going to take this and we can choose either equation. It doesn't matter which one you choose. I'm going to choose the top one for consistency. So instead of saying y is equal to 2x plus 7, I'm going to say y is equal to 2 times what x is, 1.5 plus 7. So what is 2 times 1.5? Great job. It's 3 plus 7, and y is equal to 10. So the point at which these two lines would intersect at 1.5, 10. Now, some of you may be wondering, could I still see this graphically? You can. If you wanted to double check your work because you got a decimal and you were a little uncomfortable with that, again, you can go back to your decimals page, just clear out these equations, and we'd start over. My first equation, y is equal to 2x plus 7. My second equation, y is equal to 4x plus 4. And you see how they do intersect. And if you look at that dot, 1.5 comma 10 is our solution. So again, this is a great way to double check your work to make sure that you're doing it accurately. We are going to go through the last two examples because these ones are very special, and I think you're going to realize why pretty quickly. Let's look at number 5. Oh no, this one says x equals instead of y equals. Is that going to change anything? No. The only thing it really changes that this entire piece is x. So instead of plugging it in for y, we're going to substitute it in for our x value. So instead of saying negative 2y plus x, I'm going to say negative 2y plus the entire thing that x is. Negative 4 plus 2y. And all of that is equal to negative 2. Now again, whenever you substitute in a whole expression like that, you're going to want to put it in parentheses. But in this situation, does it change anything? No, there's no number, there's no coefficient outside those parentheses. So I'm just going to rewrite this. Negative 2y plus a negative is like minus 4 plus 2y is equal to negative 2. So now if I combine my like terms, I have a negative 2y plus 2y. If I have negative 2y's and I'm adding 2y's to it, what happens to those? You are exactly correct. It equals 0. They cancel out. So the only thing left on the left-hand side of my equation is a negative 4. And we're saying that is equal to a negative 2. Is that a true statement? Are they equal to each other? No, they're not. So that is not true. This one right here is no solution. Now I am going to jump back to that decimals page one more time to show you why this is no solution. So if I were to go ahead and put these two equations in, x is equal to negative 4 plus 2y. Where do you think the other graph is going to appear? How do you think it's going to look on here? Let's go ahead and see. Negative 2y plus x is equal to negative 2. Oops, I didn't put an equal sign. Sorry about that. Is equal to negative 2. Do you see how both those lines are parallel? Remember, when they were parallel, we said no solution. All right, so let's go ahead and look at our final problem. Again, this one's going to seem pretty special to you. All right, number 6, we have 4 is equal to negative 5x plus y, and we also have 4 plus 5x is equal to y. If we look at our top equation, we have no variable by itself. So we're going to look at our second equation. Our second equation already has y by itself, so we're going to take what y is and we're going to put it in place of y in our second equation. So instead of saying 4 is equal to negative 5x plus y, we're going to say 4 is equal to negative 5x, 4 plus 5x. Okay, so again, we're substituting that back in the top equation. So now we can rewrite it. There's no coefficient outside the parentheses, so it's just 4 is equal to negative 5x plus 4 plus, oops, I forgot my x over here, 5x. And if you look here again, combining like terms, I have a negative 5x and a positive 5x. What happens to both of them? You got it, they cancel. So on the left side I have 4, and on the right side I have 4. Is that a true solution? Is that true? Is 4 equal to 4? It sure is. So this one is infinite solutions. There's infinite solutions. And what does that look like graphically? That's the big question. What is this going to look like on a graph? So we're going to go back to decimals one additional time to see what this looks like. So when I type in my first equation, 4 is equal to negative 5x plus y. Notice my line is blue. Now I'm going to type it in one more time. 4 plus 5x is equal to y. Did you see how that line changed to green? Watch that one more time. It's blue. When I type in my second equation, now it's green and it's darker because it means that those are exactly the same line. So that is why our answer is infinitely many solutions. Great job today. If you guys have any questions at all, make sure you talk to your teacher to clear up any misconceptions you have. Otherwise, I feel confident that you guys are ready to begin your homework. Just remember, when you're substituting numbers in or expressions in, you're taking out that variable and you're putting what it's equal to in its place. Great job again. Thanks and have a great day. Bye.